First of all, we're going to talk about what object-oriented programming is, how it works in general, and its four fundamental principles. Object-oriented programming, or OOP in short, is programming paradigm that is based on the concept of objects. And paradigm simply means the style of the code, so how we write and organize the code. We use objects to model, so to describe aspects of the real world, like a user or to-do list item, or even more abstract feature like an HTML component or some kind of data structure. Now, as we already know, object can contain data which we call property and also code which we call methods. So we can say that by using objects, we pack all the data and the corresponding behavior all into one big block. So again, that's data and the corresponding behavior. And this makes it super easy to add directly on the data. And speaking of blocks, that's exactly what objects are supposed to be. So an OOP, which is an acronym that I'm gonna use instead of object-oriented programming. So an OOP, objects are self-contained pieces of code or blocks of code like a small application on their own. And then we use these objects as building blocks of our applications and make interact with one another. Now, this interaction happens through a so-called public interface, which we also call API. This interface is basically a bunch of methods that a code outside of the objects can access that we use to communicate with the object. It will make more sense once we start developing this concept using code throughout this session, but why does OOP actually exist? This paradigm was developed with the goal of organizing code, so to make it more flexible and easier to maintain. So before OOP, we might have a bunch of code together across multiple functions, or even in the global scope without any structure. This particular crazy style of code is usually called spaghetti code. This spaghetti code makes it very hard to maintain. So the idea of OOP was basically created as a solution to this problem. Nowadays, OOP is probably the most popular and widely used programming paradigm in large-scale software engineering. OOP is not the only way of writing and organized and maintainable code. In fact, there are many other paradigms that have become increasingly popular, and one of them is functional programming. Functional programming allows us to achieve the exact same goal. It will make more sense once we start developing these concepts using code throughout this session, but why does OOP actually exist? This paradigm was developed with the goal of organizing code, so to make it more flexible and easier to maintain. So before OOP, we might have a bunch of codes together across multiple functions, or even in the global scope without any structure. This particular crazy style of code is usually called spaghetti code. This spaghetti code makes it very hard to maintain. So the idea of OOP was basically created as a solution to this problem. Nowadays, OOP is probably the most popular and widely used programming paradigm in the large-scale software engineering. OOP is not only the way of writing and organized and maintainable code. So in fact, there are many other paradigms that have become increasingly popular. One of them is functional programming. Functional programming allows us to achieve the exact same goal. But for now, let's focus on OOP. Now actually using object is nothing new for us at this point. We'll be using them all the time. However, up until now, we have only used object as a loose collection of data and without making them interact with one another. Also, we didn't have a way to generate object programmatically. All we ever did was use simple object literal. But in OOP, we actually needed a way to generate, so to create new object from our code. And to do that, in traditional OOP, we use something called classes. We can think of a class as a blueprint which then be used to create new objects based on the rules described in the class. So it's just like an architecture, where the architect develops a blueprint to exactly plan and describe house. But blueprint is really just an abstract plan, like a set of rules, nothing tangible that you can actually touch. However, from that blueprint, many real houses can then be built in the real world. And with the classes, it's just the same. Let's take a look at this fictional user class as an example. I say fictional because this is not actual JavaScript syntax. because JavaScript does not actually support real classes like I'm explaining here. We do have a class syntax and a JavaScript too, but it works a bit different. However, the idea of creating objects from the kind of blueprint is still very useful mental model to have, because in general terms, this is still how OOP works across all languages, and that includes JavaScript. So that's the reason why I'm showing you this here. But anyway, back to our fictional class here, we can see that it kind of describes a user who has a username, password, and an email. So it's a description of the data about user. But it's not data itself yet, because remember, the class is really just a plan. And a plan does not contain the real world data yet. On the other hand, we have the behavior that is associated with the data. In this case, that is just a login method, a method to send messages. This class has everything related to a user, data, and behavior. But now let's use this class and actually create a new object from this class, and you see that now we actually have a real data about the user and the object, and not just a description of the data like we have in the class. So in the plan, now we call all object created through a class instances of that class. So again, an instance is a real object that we can use our code. Now we can use this class to create as many instances as we need in our application, just like we can build multiple houses from just one blueprint. So we know how classes work, but next logical question is how do we actually design a class, or another word, how do we actually model real world data into classes? This question is just like an architecture student asking how do we actually plan and design a house? The answer is not straightforward, so there is no single correct way of designing classes. However, there are four fundamental principles that can guide us to work a good class implementation. These principles are abstraction, encapsulation, inheritance, and polymorphism. These are actually techniques that can also be used outside of OOP. So let's now take a look at each of them. The first one is abstraction. Abstraction basically means to ignore or to hide details that don't matter. This allows us to get an overview perspective of whatever it is that we are implementing, instead of messing with the details that don't really matter to our implementation. So let's say that we are implementing a phone. So without abstraction, we could design our class to include everything that there is about the phone, including all the internet stuff like a verified phone temperature and voltage, speaker, and so on. But as a user interacting with the phone, we do not need to know all the details. All of this detail has been abstracted away from us as the user. And all that we are left with a simple phone that we basically only interact with using the home button, volume buttons, and the screen. Everything is gone because we simply don't need it as a user. That's exactly what abstraction means. Now we go back to the example of user from the last slide. We could implement a user phone number, mailing address, hair color, shoe size, and tons of other stuff that we might not need in our application. So we simply ignore this detail. Now abstraction is really important, not just in OOP, but in programming in general. In fact, we create and use abstraction all the time. For example, take an event listener function that we use all the time. Do we really know how exactly it works behind the scene? We don't. And do we care? Not really. And we do have to, because once more, the low-level details of how exactly it works has been abstracted away from us. We are simply the user, so we can simply use that function without completely understanding it and without having to implement it ourselves. So that is abstraction. So the next principle is encapsulation. Encapsulation basically means to keep some properties and methods private inside the class, so they are not accessible from the outside the class. However, some methods can of course be exposed as a public interface, which we call API. And this is exactly what I meant at the beginning when I said that interactions between objects happen through public interface. And go back to our example of user from before. This is what private properties might look like conceptually. And again, I'm talking hypothetical here, because this private keyword here does not exist in JavaScript. But anyway, as we already know, so outside the code we cannot access these properties. However, inside the class, they are still accessible. For example, password is necessary in the login method. and so there we can use it. And by having these critical properties nicely encapsulated like this, we prevent external code from accidentally manipulating this internal state. And by the way, the turn state simply refers to an object's data, okay? Anyway, this is really important because allowing external code to manipulate internal state directly can cause many kinds of bugs, especially in large code bases and developer team. Now, as you see, there is also private method here and the check span method. Again, it is not accessible from outside a class, but it is used internally to check if a comment is spun or not. So we want no one else outside the class to be able to use this method. And so basically we don't make it part of the public interface. So the public interface is essentially all the methods that are not private so that they are not encapsulated. So making methods private make it easier for us to change our code without breaking code from the outside, which will rely on some of these methods. For example, if the check span method was public, then it could be used anywhere in our code. And if we then change the implementation of the method, it might break that code that is relying on it. So again, this helps avoiding bugs and also spaghetti code. And really, this is not just some theory, this is a real practical scenario. So there is a real reason why encapsulation and private methods and a property exists. So in summary, we should always have the goal to nicely encapsulate some of our state and methods and only leave it essential method public for the reason that I just explained. Next up, we have inheritance. So let's say we have these two classes, user and admin. As we can see, they have actually a lot in common. In fact, admin has all the property and methods that user has, and that actually makes sense because if you think about it, admin is also a user. So admins also need a password and email, and he also needs to log in, for example. However, if we design our classes like this, so as two separate identities, we will end up a lot of duplicate code, and we already know that that is bad, right? So that's where inheritance comes into play. So in OOP, when we have two classes that are closely related, like a user and admin here, we can have one class inherit from the other. So we will have one parent class and one child class, and the child class then extend the parent class. But what does all of that actually mean? So just like you as a child probably inherited some feature of your parents, a child class inherit all the property and methods of its parent class. Now in more formal terms, inheritance makes all property and methods of certain class available to a child class, which of course form a hierarchy between these two classes. And the goal of this is to reuse logic that is common to both of the classes. In this case, both admin and user need to log in. And so, instead of writing that logic twice, it makes sense to inherit the login method from the more global class, which is parent class, user to more specific class, which is child class admin. So now, of course, child class then also have its own method and property. So at the end of the day, the child class ends up with some methods of property from its own parent and some of its own. So we can say that the admin is also the user, but basically an extended user. So some added functionality. Finally, the last principle is polymorphism. Polymorphism comes from Greek, where it is literally means many shapes or many forms. Now in the context of OOP, in simple terms, polymorphism means that a child class can override a method that is inherited from the parent class. And here are our user and admin classes again. But now we also have a third class, which is other. Now admin and others are both really just special kinds of user. And so it makes sense that they both inherit from the user class, just like we studied in the last slide. Therefore, they inherit all the property and methods from the user class. But we're going to focus on the login method now. Let's say that admin require a special kind of login method. For example, a more secure one, which has two-factor authentication. And let's say that we also need a special login method for others. So how do we give them different login methods? Well, it's actually quite simple. In each class, we simply just write a new method, which is also called login. And then, according to the polymorphism, that login method will override login method that has been inherited from user class. And that's actually it. That's all you need to know about the polymorphism. And actually, that wraps up these introductions to object-oriented programming. Now, next up, we're going to talk about how oriented programming actually looks like in JavaScript. Because as I said in the beginning, it is implemented in a different way from what I explained here in the beginning with the classes and the instances. It's still crucial to understand that we will see how JavaScript does it.